Hello and welcome to the video on 3D representation. It is convenient that a 2D drawing is represented of a 3D model on paper or a 3D molecule on paper. While writing the configuration of optical isomer, the 3D structure is represented in a planar form on the paper. There are three important methods for such representations, that is Fischer projection, Seahorse projection, and Newman projection. In this video, we'll be looking about Fischer's projection. The molecule is drawn in form of two lines with the chiral atom at the intersection of the horizontal and the vertical lines. To make a Fischer projection, to view a chiral center so that the substituents are coming out of the plane. The two substituents are going back to the plane. Every cross on the Fischer projection is a chiral center. The horizontal bonds are coming out of the planes of the paper towards the observer, as if to hug them. And the vertical lines represent the bond going away from the observer, that is behind the plane of the paper. The Fischer projection should not be taken out of the plane, but it can be rotated 180 degrees in the same plane. The rotation of the formula by any other leads to the change in the configuration. The groups attached to the chiral carbon may be interchanged by clockwise or anti-clockwise direction. An example of such projection would be, here I have written an example for the Fischer's projection. Here the intersection, all are chiral carbons. Here you can see there are two intersection points that are in the center over here and over here. These two are the chiral centers, and these are the horizontal planes and these are the vertical planes. That is it for Fischer projections. In the next video, we'll be seeing about the Sawhorse projection.